Patriots, in this video we are going to talk about how to find the volume of a pyramid and what makes a pyramid and the parts of the pyramid that we care about. So a pyramid is a polyhedron. A polyhedron is just a shape that's a three-dimensional shape that's made up of two-dimensional shapes. It will have a base, and that base can be any polygon, and three or more triangular faces which meet at a point called the apex or the vertex. So the triangular sides are called lateral faces to distinguish them from the bases. So when we are looking at a pyramid, again, the most important part is the base. The base on a pyramid is the part that's usually not the triangle. So there is my base. And then at the top, we have apex or vertex, depending on how you call it. I use them interchangeably in my classroom, so I usually use the word vertex, but every now and then I'll say apex, but usually I say vertex. So in this pyramid, I know it's a pyramid. Notice the bottom, the base is some kind of quadrilateral. And the four sides, one for every side of the base, are all triangles, and it meets at the vertex. So this would appear to be a rectangular pyramid. And it's rectangular because the base is a rectangle. The one on the right, if we look, the base is a triangle. There is my base. The top again is called the vertex. The lateral faces are triangles. There's three of them. And this is a triangular pyramid. Triangular pyramid. I forgot how to spell triangular there for a minute. And then lastly, this is a circular pyramid, but if you say circular pyramid, you are going to be the only person saying that. The bottom right here, the base, I keep saying bottom, but base doesn't have to be on the bottom. A lot of times it is, but it doesn't have to be. So this base of this pyramid is a circle, but like I said earlier, no one says circular pyramid. We say cone. Nobody says circular pyramid. You'll be all alone if you do it. When we are looking for the volume of a pyramid, you might notice this part right here, the big B, the little h. That's the volume of a pyramid. I'm sorry, of a prism. Of any prism, we're going to take 1/3 the volume of a prism, and that gives me the pyramid. 1/3 area of the base times the height of the pyramid. The height, and I'll show you the height here in a minute. So big V is going to stand for volume. V is the volume is measured in 3 dimensions: length, width, and height. Big B is the area of the base, and that's in square units. And little h is the height of the pyramid. The height of the pyramid is the perpendicular distance between the base and that vertex of the pyramid, the apex of the pyramid. As a reminder, the difference between a capital letter and a lowercase letter in geometry: capital letters we calculate, lowercase letters we can measure. All right, so let's go to the parts of the pyramid that are going to be used to find the volume. Well, as a reminder, we just saw it, but you know what? Let's talk about it again. Volume of any pyramid is going to be 1/3 area of its base times its height. So area of the base, let's make that big B. That is going to be right here. There's my big B. And then the height of the pyramid is the distance between the apex and the base. Little h is real easy to find. It is a measurement, but remember, capital B is going to be something that we are going to figure out. Because this is a hexagon, we went over this in the last video, we're going to say 1/2 perimeter times apothem. And I'll even take it a step further. Let's say what this is. This is a hexagonal pyramid. Look at all the things that we are picking up here. Learning so much. Our next pyramid, we notice big B. The base itself is a circle, and we're going to talk about how to find it here in a minute. And the height is the distance between the apex and the base. To calculate big B, because this is a cone, big B, pi times radius squared. Notice in this picture they didn't give us radius, they gave us diameter. So we would have to cut that radius in half. And then our last one, when we find the base is right here. I notice that all the sides are the same. So we're just going to do length times width because all the sides are the same. It is a square. And we need to know the height, and the height is the distance between the apex of the pyramid and the base of the pyramid. So boom. There we go. And that is what we're going to do when we get into class tomorrow. We will find the volume of these pyramids by using our formula and identifying those parts. So here's a volume fun fact. How many cones will it take to fill a cylinder of the same size? Not only a cylinder, but any pyramid to any prism that has the same base and the same height. So what I want you to notice here, both of these B's are a circle, and the area for any circle is pi r squared. Well, we'll notice that both bases have the same radius. So from left to right, I know big B equals big B, 25 pi and 25 pi. And if their heights are the same, a height of 10 and a height of 10, then the heights are equal to each other because 10 equals 10. So when we figure out their volumes, the volume of the cylinder is area of the base times the height. The area of the cone, the volume of the cone is 1/3 times area of the base times the height of the cone. So notice we're going to take the volume of a cylinder and we're going to divide it by 3. So how many cones will it take to fill the cylinder? So the volume of 3 cones is the same as the volume of 1 cylinder because of the 1/3 in the formula. That's true for any pyramid, not just cylinders and cones. It's true for all prisms and the pyramids that have the same base and the same height. So fun fact, lots of fun. Lots of fun. Alrighty, so if you have any questions, please jot them down. And Patriots, come in class ready to participate or have those questions as soon as you are done watching this video. And Patriots, we will see you when we see you.